purpose of this video is for you to be able to look at data and then understand what kind of data you have, and as well as, when you know that, to make a graph based upon it. So data can be really separated into two categories. It can be either qualitative or quantitative. Qualitative data is like plaid, black, yellow, red. These are things that are non-numbered. Qualitative data can also be categorical in that it can be separated into specific categories, like colors could be separated into certain categories. It doesn't necessarily apply to all qualitative data, but it could. On the other hand, quantitative data is numerical data, that involves numbers. Now, you can either have discrete or continuous data, and discrete data is data that have values that are distinct from each other, and it's typically counted, and there's no in-between values. For example, like the day, the month, the number of people are some examples of discrete values, of discrete qualitative data, whereas continuous data is types of data that is measured, height, volume. That's stuff that's got an in-between value between the measurements that it could exist, and those are the different types of data. Now we're going to talk about the different types of graphs that we're going to make, or you could make with your data. There are 5 types. There's pie, bar, histogram, line, and scatter plots. There are other types of graphs. These are the 5 that we're going to cover. A pie graph is categorical and quantitative. It represents the part to a whole. The second type of graph is a bar graph, and a bar graph is like a pie graph in that it's categorical as well as quantitative, but this is meant to compare different things to each other to represent which one was the best, which one was the most frequent, which one was the funniest. The third type of graph is a histogram, and a histogram is a specific type of bar graph where your x variable has been chunked together into categories, so to speak, but it's quantitative data that's been chunked together. So I've got like 1 to 3, 3 to 6, and so on, and that's represented. It's being graphed against something you've measured for these specific categories. I have here hours slept per night. And one important feature of a histogram is the bars should touch. There should be no space between them. Now, the next graph is a line graph, and a line graph where you've got continuous data that like time, mass, volume, and your independent variable is always here on your x-axis, as it is in other graphs. And one important feature of a line graph is that your independent variable, each incremental measurement depends upon the last one. So I would need to know this measurement before I was able to do any of the other measurements. The last graph is a scatter plot, and a scatter plot is when you collect a series or a set of different data points that don't really depend upon the last one. So I took several different measures of mass and measured their volume and then plotted against each other. Once again, you always graph your independent variable on the x-axis, and these are really used to look for a line of best fit. A line of best fit is some sort of, it's not straight, it should be straight, some sort of line that represents your data. And those are the types of graphs.